for the lesson on parallel and perpendicular lines. And we're going to start with a warm-up featuring some of the previous topics in this unit. So warm-up time, question 1. If A is this coordinate and B is this coordinate, find the distance of the line AB. So of course we're using the distance formula. And remember, the thing I always nag you to do is to label one of the coordinates x1, y1, label the other coordinate x2, y2. So you could have called this one x1, y1, you could have called this one x2, y2. You'll get the same answer in the end anyway. The thing you can't do is call this one x1, y2 or x2, y1. It has to be the same number, x1, y1, x2, y2. So distance formula, remember the distance of line AB, you're going to do the big square root sign, and you're going to put in, well, that's a distance formula. If you forget, you might want to write it down because it is something you do need to remember. So the distance of line AB will be the big square root, it's Pythagoras' theorem, of x2 minus x1 all squared plus y2 minus y1 all squared. That gives you the horizontal and vertical length of the right angle triangle formed. And what you do is you substitute in the values. So because you've labelled x1, y1, x2, y2, it's easy to sub them in. x2 minus x1 is 2 minus negative 6. y2 minus y1 is 7 minus 1. You could have had it the other way around, y2 minus y1 squared, x2 minus x1 squared. It's okay because you're adding them, so it doesn't matter the order. So then pop them in, and then you can plug it into the formula just like this. Just reminding you that you can do it easily. All you have to do is activate your big square root sign. So I need to calculate, and you need a big square root sign. And then you can start to use the brackets and that kind of thing and start to fill things in. So just make sure that you would do that, and that you would use the subtract button for this and the negative button for that. So in case you're not sure what I mean by that, so we've got 2 subtract negative 6. Notice I put the negative in green to indicate that's a negative. So just reminding us that's a negative, and when you do that, you actually end up getting an answer of 10. So the distance between these two coordinates on a graph is 10 units. And just a reminder that we use a negative button for this one. Maybe now let's move on to the next question. And notice the next question actually is still referring to the same coordinates. So the gradient of AB. What I've started to notice from topic assignments and other sorts of things is that it can benefit students a lot to, next to the question, write the coordinates out again. Sometimes if people have them further up on their page, they're starting to make errors when they substitute into the formula. So a good idea is, even though you've got the coordinates up here, maybe just write them down next to the question that you're actually answering now. Because I do have started to notice people make little errors if they don't do this. Because you've just got too many numbers on the page. It's too much going on in your brain at once. So make it easy on your brain. Have it right there. And just make sure you copy them down correctly. So the gradient of AB, so x1, y1, x2, y2. Remember the gradient formula? So I think, what is it again? Little m equals, can you remember? That's right, it's y2 minus y1 over x2 minus x1. This is the rise, this is the run. So the gradient equals rise over run. We use little m for the gradient. Don't use uppercase M, because uppercase M, what does that stand for again? That's right, that stands for the midpoint. So let's substitute in y2 minus y1 on the top. So y2 minus y1 on the top, and then x2 minus x1 on the bottom. x2 minus x1. Again, negative button. You can put it straight into the calculator like this if you like. Let's just clear this one. Control clear. So remember, you've got a nice fraction button. So you might want to use this little fraction button, see above the divide sign. So go Control Divide on the Inspire, makes a nice fraction button. So 7 subtract 1, for example, over 2 subtract negative 6. And you just press enter to get your answer. So that, if you were to do it by hand, by the way, 7 minus 1 is 6, 2 minus 6 is 8. This could be a non-calculated question. And on your calculator, notice you got 3/4, or you could write it as a decimal. So you could write it as a simplified fraction, 3/4, or you could write it as a decimal, 0.75. Both are correct. Just be aware that this could be on a non-calculator paper, these kind of questions. So one like this, for example, could have been on a non-calculator because you've got a nice whole number. And that's because 2 minus negative 6 is 8, 7 minus 1 is 6, 8 squared plus 6 squared is 64 plus 36, which is 100, Square root of 100 is 10. So just, you might like to try things without calculator as much as possible, but if you're starting to get into weird decimals and stuff like that, then you might want to, you could leave answers as simplified thirds, or not. Okay, let's just go into the lesson. So parallel and perpendicular lines. You might have heard a little bit about parallel and perpendicular lines in an earlier year, like year 7 or year 8 or something like that. Just remembering what parallel lines are, like remember parallel lines, they have the same kind of gradient. So parallel lines, for example, could be kind of, let's do a little line. So you don't have to do this if you don't want, I'll just do a little demo. Here's a line. So a line parallel to that would kind of be at the same slope. Control C, Control V. Here's a line parallel. So notice when I did this, these two lines are parallel. They're kind of going in the same direction. Whereas perpendicular would be moving, they would intersect at right angles. So these two lines are parallel, but these two lines are perpendicular, meaning that they meet at a right angle. So here's an example of perpendicular lines. Parallel lines, sort of, some people say the definition is that they never meet, but you could have some non-parallel lines that never meet as well. So they're kind of like moving, like, you know, the equal distance apart, parallel lines. What do I mean by that? I'll just show you again. See that the distance between them is constant as well, and they also never cross and that kind of thing. Perpendicular lines, by definition, meet at a right angle. They cross at a right angle. So I'll just get rid of that. Back to here. Sketch the 3 lines on the number plane, next page. So how do you sketch a linear line, like a straight line like this? So one thing you might want to remember, this number here, what does it represent? It represents the y-intercept, and this number here represents a gradient. So that might be kind of interesting. What you can do is you can calculate the x and y intercepts of both graphs, and then you can just plot the x-intercept on the x-axis, plot the y-intercept on the y-axis, and just draw a line between them. So I'm going to do that. I'm going to find the x and y intercept of each of them, and I'll show you this is the method I'm using to do that. Sorry, back to here. So line A. So the way we find, I tend to make a little table. So I make a little cross table, and I'm going to work out the x-intercept value on the left, and I'm going to work out the y-intercept value on the right. So the x, and one thing to note on a coordinate plane, so here's your coordinate plane, at the x-intercept, what is the value of y always equal to? The y value would always be 0. At the y-intercept, what is the value of x? So here's your coordinate plane, y-intercept's here, the value of x would always be 0. So you could go straight to x at the x-intercept, y is 0, at the y-intercept, x is 0. And then what you can do is you can just substitute that into the equation. So the equation is y equals 2x plus 8. So if at the x-intercept y is 0, so replace the y with 0, so 0 equals 2x plus 8, but at the y-intercept x is 0, so y equals 2 bracket 0 plus 8. And then you just start to solve them separately. So negative 8 equals 2x, we've subtracted 8 from both sides. In this case I just substituted in 0, so 2 times 0 is 0. So we've got the y-intercept, y equals 8. But then for the x-intercept we just have to keep solving. So to be honest, you could work out the x-intercept all first, then work out the y-intercept after that. That might be easier. So to solve for the x-intercept you need to divide both sides by 2. Negative 8 divided by 2 is negative 4. And then you can write those as coordinates. So the x-intercept is this coordinate, negative 4 and 0, because y is 0, x is negative 4. The y-intercept is this coordinate, 0, 8. Which we'll end up drawing on the graph on the next page, but we'll just find all the x and y intercepts first. And here it's just asking us to summarize that. So notice that these are just coordinates. You don't actually even need to have this table there. You could just write the answers here if you prefer. So if this table is annoying you, you can just ignore it. These are actually what I'm meaning by these, meaning the x-intercept is this coordinate here. So x-intercept, so we've got 0, 8, and negative 4 and 0. So they're actually coordinates. So if you find this part annoying, just ignore it. So that's the x-intercept, that's the y-intercept is probably better. The next line we're going to do is B, and the equation is y equals 2x minus 2. So same thing as before, we're going to set up this table, x-intercept, y-intercept. So x-intercept, y-intercept, have that set up. And remember at the x-intercept, what is always the case? It's always the case that y is 0. And at the y-intercept, it's always the case that x is 0. So So let's write that out. Always a good idea to do that. And then you just separately substitute into the equation of line B. So if y equals 2x minus 2, we're going to substitute in 0 equals 2x minus 2. And so on. So maybe let's just look at the x-intercept first. Now to solve for this, we need to add 2 to both sides. So 2 equals 2x. Then we need to divide both sides by 2. X equals 2 divided by 2, which is 1. So x equals 1, y equals 0. For the y-intercept, x is 0. Substitute in x is 0 into the equation, y equals 2x minus 2. And then you just get y equals negative 2. So there's your x-intercept that we're going to plot. Then on the next page, you're going to plot the y-intercept. And you just connect them up with a straight line. And then that's how you draw your graph. The last line is line C. Y equals negative a half x minus 4. Fraction in there, a bit awkward. X-intercept, y-intercept. At the x-intercept, y is 0. At the y-intercept, x is 0. Let's look at the x-intercept first. So this is the equation of the line was y equals negative a half x minus 4, which we got from above here. And then let's look at the green one side first. So how would we start to solve that? We would add 4 to both sides. 4 equals negative a half x. How would we solve this? We could divide both sides by negative a half. Or another way of thinking of it is multiply by 2 and then divide by negative 1. That also works. So I just did 4 divided by negative a half, just because I find that easy to do. 4 divided by negative a half is negative 8. So as I said, the other way to do it would be multiply 4 by 2, so then 8 equals negative 1x, and then divide by negative 1. So x equals negative 8. So the x-intercept is at negative 8 and 0 coordinate. The y-intercept you substituted in x equals 0. So y equals negative a half 0 minus 4. And that becomes 0, of course, because anything multiplied by 0 is 0. Y equals negative 4, and here's that coordinate. Now what we're going to do is we're going to plot these 3 lines on the next page. So you'll start to see the next page. I've plotted these points. So to start with, let's just look at line A. Plot this point, negative 4, 0, and 0, 8. Next line. So negative 4 and 0 is this point here. 0, 8 is that point there. See there the x and the y-intercept? And then you just rule a line between those 2 points. So here's your first point, x-intercept. 0, 8 is your y-intercept, and rule a line between them. And label it line A, of course. And then the next one we had to find that we found was this one. Line B, 1, 0, 0, negative 2. So we're plotting these coordinates. 1 and 0, 0 and negative 2. And then you just rule a line all the way through them. Don't just rule between here, just extend it on. And label it line B. And it makes sense too, doesn't it? Because the gradient's 2, so each time you go across by 1, you go up by 2. Across by 1, up by 2. Line C was the other one, so its x-intercept was negative 8, 0. Its y-intercept was 0, negative 4. And then you rule a line connecting it up. It makes sense because notice that the positive gradients from left to right you're going upwards, and the negative gradients from left to right you're going downwards. Because positive gradient, negative gradient, which is why. And label that one line C, of course. And it makes sense because as you go across by 1, you're going down by a half. Across by 1, down by a half. Across by 1, down by a half. Whereas these both had gradients of 2. Across by 1, up by 2. Across by 1, up by 2. What do you notice about them? So then you're asked a few questions about the graph. What do you notice about line A and line B? Line A and line B, they are parallel. So they are parallel. Line A and line B, they are parallel. Then you're asked, what do you notice about line A and line C? So line A is the green one, line C is the red one. And it's hard to tell exactly, but it's meant to be that they're perpendicular. They are perpendicular, they meet at right angles, because it's meant to be a right angle here. Just turns out that way. What do you notice about line B and line C? Line B is a black line, line C is a red line. Same thing, they're perpendicular. They are perpendicular, meaning that they are at right angles. And can you remember from the equations of line A and line B on the previous page, what did they have in common? That's right, what they had in common was, I'll come back to here soon, what they had in common was they had the same gradient. So if they have the same gradient, they are parallel. That's one little clue. So same gradient means that they are parallel. Now let's move on to the next page. As we just pointed out, parallel lines have the same gradient, and I just drew in some parallel lines here. And remember the way we sometimes indicate parallel lines on diagrams anyway, more so than on graphs. We just put the little arrows to indicate that they're parallel. So what's interesting about you might not realize what I'm asking here, the gradients of perpendicular lines multiply to give -1. So the gradients of perpendicular lines just happen to multiply to give -1. Here's some perpendicular lines, they cross at right angles. And by that, I mean, for example, like say you might just want to put a little example in here. So the gradient of line A was 2. The gradient of line C was -1/2. So what is 2 times -1/2? This is from the 2 pages before. 2 times -1/2 happens to equal -1. So that's based on the previous 2 examples. So the gradient of line A was 2, the gradient of line C was -1/2. 2 times -1/2 gives you -1, and those lines were perpendicular to each other, meaning they met at a right angle. So that just happens to be the case. Parallel lines have the same gradient. Perpendicular lines, their gradients multiply to give -1. Typical exam questions require you to show knowledge of these rules. So that could be possible. For example, you might be asked to show that these 2 lines are perpendicular, and maybe you were given their equations. So the way you would show that they were perpendicular is you would take their 2 gradients from their equations and multiply to prove that they equal -1. Here's a little example. Write down the equation of a line, any line, parallel to the line with equation y equals 4x minus 9. So what is the gradient of this line? That's right, it's 4, because this is a y-intercept, this is a gradient. So the gradient of this line is 4. For it to be parallel, it must have the same gradient. So just make sure, so maybe marking gradient is 4, make sure that you've got a line that has the gradient being the same. Doesn't matter what the y-intercept is, so you could have y equals 4x plus 10, you could have y equals 4x, you could have y equals 4x minus 8. Why can't you have y equals 4x minus 9? Have a think. That's because it would be the exact same line as the original one. So we're talking about, we want the equation of another line that is parallel to this one. So this one would have a y-intercept of 10 and a gradient of 4, so it would be parallel to this one. That's why I said any y-intercept okay except for -9, because otherwise that would be the original line. Next question, write down the equation of a line perpendicular to the line with this equation. Y equals -1/4x plus 5. So think, what is the gradient of this one? The gradient of this one is -1/4. So a way to think about it is these two, try to think these 2 lines, these 2 gradients are from perpendicular lines. So notice what's special about them. You'll notice that if one is negative, the other has to be positive. Vice versa, if this was positive, that has to be negative. One has to be negative, one has to be positive if they're perpendicular, because it makes sense. One's going upwards from left to right, one's going downwards from left to right. On top of that, what do you notice about them? So you might realize that the 2.5, they're the reciprocal of each other. Do you remember the concept of a reciprocal? The reciprocal of 1 over 2 is 2 over 1, which is just 2. 2 divided by 1 is 2. So they are, you would say that they're the negative reciprocal of one another. So meaning that you change the sign and you flip the fraction. 2 written as a fraction would be 2 over 1. So if you flip it and make it negative, you get -1 over 2. So let's apply that concept here. Gradient must be the negative reciprocal of -1/4. So what you have to do is to find the negative reciprocal, you've got to change the sign to a positive, and you do the opposite of what it was. It was negative, so change it to a positive and flip it upside down. So to become +4 over 1, which just simplifies to give you 4. So the equation must have a gradient of 4, and these were, over here I've just got little examples of other perpendiculars, so you don't have to have those there. For example, if a gradient was 1/2, its negative reciprocal would be -2 over 1. If there was a gradient of 5, its -5, its negative reciprocal would be +1 over 5. So if they might be confusing in the future, so feel free to erase those if you want. So an example of a line perpendicular would have to have a gradient of 4, and so y equals 4x, it could have any y-intercept. at all, because you've already got a different gradient, so it's already a different line. So you could have even +5 if you wanted as the y-intercept, because it's a different gradient, so it's already going to be a different line. Write down the equation of a line parallel to the line with equation 10x minus 2y equals 6. So you've got to, first of all, to work out what the gradient is, you've got to rearrange to make it y equals. So try to think to rearrange to make it y equals. There's different ways you can do it. How did I start? I've written, first of all, what I chose to do is I chose to just swap these two over. So I added 2y over here, and I subtracted 6 over here. There's different ways you can do it, so long as you get the same final answer. So add 2y over here makes positive 2y. Subtract 6 from here, you get 10 minus 6 equals 2y. And then to get y by itself, what do? That's right, you divide both sides by 2. So divide by 2 becomes y. I went straight to breaking up the numerator. 10x over 2 minus 6 over 2. You could have started with 10x minus 6 all over 2 and then broken up the numerator, because you're allowed to break up a numerator. 10x over 2 will just give you 5x. 6 over 2 will give you 3. So the equation is y equals 5x minus 3, so the gradient is 5. So now we've got to come up with another line with the same gradient, because it's parallel, and a different y-intercept. Otherwise it would be the same line. So for example, you could have y equals 5x plus 2. You can't have 5x minus 3, or else it'd be the exact same line. You could have had any other y-intercept, sorry, except for negative 3. You could have even had y equals 5x. Okay, let's keep going. Go to the next 2 pages. Line A and B are parallel in this example. Parallel meaning going at the same direction and equal distance apart the whole time. Line B and C are perpendicular. So parallel, remember, has the same gradient. Perpendicular, their gradients must be the negative reciprocal of each other. So complete the table below. Gradient of line A, if line B is parallel, must have the same gradient, and line C must be the negative reciprocal of that. So same gradient for these two, negative reciprocal for that one. So 5 is the same as 5 over 1. Flip that, you get 1 over 5 and change the sign. So for 7, same gradient, and you would get negative 1 over 7. Okay, negative 4 is the next one. So negative 4, same thing here, negative 4. I just changed this to negative 4 over 1 just to illustrate the point that you can flip that to make it positive 1 over 4. Same. So feel free to fill in the rest and pause, and then I'll and then unpause once you've filled in the rest, and you can check them. Okay, so assuming you've done them all, now you can check your answers. Give you a little moment to look at that. So I've already seen that one. So feel free to just check your answers. Pause if you need to, because we're just about to go into the next page. So hopefully you tried that yourself first, and now you're checking any answers. Feel free to pause and also ask me or email me if you've got any questions. Okay, on to the next page. Last page for our lesson, I think. Yes, it is. So 2 lines have gradients -5 and 5 respectively. Are the lines parallel, perpendicular, or neither? So it's pretty obvious they're not parallel, because they're not exactly the same. -5 and 5 aren't exactly the same. Are they the negative reciprocal of each other? No, they're not. So there's different ways you can say it. They are neither, because it's parallel, would have the same gradient. So e.g. -5 and -5, but we have -5 and +5. They were perpendicular, what would be the case? The gradients would be the negative reciprocals of each other, e.g. -5 and +1/5. Last little example. 2 lines have gradients -3 over 4 and +4 over 3 respectively. Are the lines parallel, perpendicular, or neither? So, but you'll be on there. So it's pretty obvious that they're not parallel, because they're not exactly the same. -3 over 4 is not the same as 4 over 3. But they are perpendicular, because they are the negative reciprocal of each other. So they are the negative reciprocal of each other. You can look at it this way. So -3 over 4, you would flip it, you would get 4 over 3. And also then you would change the sign to a positive. Another way to check is, remember that by definition, if they're perpendicular, these 2 gradients would multiply to give -1. So -3, let's see, so -3 over 4 times 4 over 3. 3 times 4 is 12, 4 times 3 is 12, and 12 divided by 12 is 1, but also you've got a negative times a positive, so it would be -1. And that's the end of the lesson.